So, welcome back. We will continue our discussion on astable multivibrators, and in the previous session we looked into the applications of monostable multivibrator. We had worked few problems on monostable multivibrator, and we also looked into the use of 555 timer as an astable multivibrator. So, just to recall, your 555 timer as an astable multivibrator requires 3 external components, 2 resistances RA, RB and C. We looked into the circuit diagram. We also tried analyzing how an astable multivibrator works, and we have arrived at an expression for on period and off period. So, it is T on. If you can recall the expressions which we had derived in the previous session, it is 0.693 because the capacitor gets charged to RA and RB. So, it is 0.693 RA plus RB into C, and T off is 0.69, it is discharging through RB into C. At this point, so if you can recall, this was how the output waveform looked like. So, if you can see, this is your total time and T on and T off. What observation you make here is the on time is obviously greater than off time because of this expression. So, it is getting charged through RA and RB, and it is getting discharged through RB only. So, the on time is obviously greater than off time. So, we will define what is called as duty cycle at this point. So, duty cycle is the ratio of on time by the total time. So, it is T on by T on plus T off. So, you substitute these values, you end up getting T on is 0.693 RA plus RB into C divided by 0.693. If I take common, it is RA plus 2 RB into C. So, it is going to be RA plus RB by RA plus 2 RB, and it is always, if you see the duty cycle, it is always greater than 50%. So, most of the time it is on. So, because the denominator is greater, so it is always greater than 50%. So, we will see what can be done to bring this to 50% in our subsequent discussion. So, we will, at this point we will jump to the various applications of your astable multivibrator. So, we will list these applications and try to discuss each one of them one by one. So, the applications of astable multivibrators. So, the applications of astable multivibrator includes a square wave generator. As you saw from the waveforms you observed, the output of an astable multivibrator is usually a rectangular wave. So, that is because the on time is greater than the off time. So, you tend to get a rectangular waveform. So, what modification is to be done on a basic astable multivibrator to convert it as a square wave generator? We will study as the first application, that is application of your 555 timer as a square wave generator. And next is a free running ramp generator. So, ramp generator with few modification, you can see that your astable multivibrator can be converted to produce a waveform, ramp waveform, something like this. And we also have voltage controlled oscillator. So, when I say voltage controlled oscillator, so we output oscillations, the frequency of your output signal is dependent on the voltage. You increase the voltage, you increase or decrease the voltage, the frequency is going to increase or decrease. So, thereby converting your basic astable multivibrator into voltage controlled oscillator. So, we will see this application in detail, and it can also be used as frequency shift keying. So, these two are behind the scope of our syllabus. So, we will focus on the use of Astable multivibrator as a square wave generator and also as a voltage controlled oscillator. So, we will take up one by one. We will take up the application of your Astable multivibrator as a square wave generator and a voltage controlled oscillator. So, we will take the first application, that is use of an Astable multivibrator as a square wave generator. So, if you look into the basic Astable multivibrator, it is something like this. 8 is a power supply, 4 is a reset connected to VCC. Between 8 and 7 we have a resistance RA, 7 and 6 we have resistance RB, and 2 through 2 I connect the capacitor C, and 1 is a ground, 5 is a control pin which is usually kept connected to the ground through a capacitor, and 3 is your output voltage, and this is your basic 555 timer. And if you can see, T on is RA plus RB into C, 0.693 into RA plus RB into C, and T off is RB into C. Now, at any point of time, it is going to generate a rectangular wave because the on time is greater than off time. So, we should see, if you want it to be a square wave generator, we should see to it that the on time and the off time, they are equal. To ensure the on time and off time are equal, we should see to it that it is getting charged through RA and discharging through RB, bypassing RB while getting charged. So, what I do is I connect a diode across RB. So, what happens here is, during charge, when the capacitor comes across VCC, when the discharge transistor is in cutoff, it is disabled, the capacitor comes up across your power supply, it starts charging through RA and RB. Because I have connected a diode in parallel with RB, what happens is, the capacitor gets charged through RA and forward bias of your diode, thereby bypassing this resistance. Parallel combination of this is going to be less than the forward resistance, and forward resistance of a diode is very negligible. As a result, I can write the charge time of your capacitor as RA into C, 0.693 RA into C, because it is diode has been connected across RB, thereby the parallel combination, it is going to be negligible, making your charge time as 0.693 RA into RC. Now, when the capacitor starts discharging, what happens is, it discharges through RB, and this diode is reverse biased, producing a very high resistance, and thereby the capacitor finds its discharge path through RB and RB. So, your discharge time is going to be 0.693 RB in C. Now, I am choosing equal values of RA and RB, I can see to it that a square wave is generated. So, just by an addition of a diode across RB, your rectangular wave generator, a free running Astable multivibrator, can be converted into a square wave generator. So, with this we will take up the next application, one more application of your 555 timer, that is use of 555 timer as a Smith trigger. So, you are aware what a Smith trigger is. Smith trigger is a circuit which converts irregularly shaped any waveform into a square wave waveform. So, what we do is and the Smith trigger, it has two threshold points, an upper threshold point and lower threshold point. When it crosses upper threshold point, it jumps from one saturation level to other saturation level, and when it crosses lower threshold point, it jumps back to the other threshold to the other saturation level. So, using this concept, we can use a Smith trigger, we can use a stable multivibrator to construct a Smith trigger. So, your Smith trigger is basically a circuit with 2 trigger points, or you can call it as a wave shaping circuit, wherein you give any input, it produces a square wave. So, here what I do here is, we have a basic stable multivibrator which looks like this, 8-4, see between 8 and 7 we have resistance RA, and 7. So, here I will make a small modification, 6-2 RB I will bring here, and capacitor is, and I apply the input sinusoidal voltage through the capacitor to the resistance R, and 1 is ground, 5 is control voltage which is kept grounded using 0.05, and 3 is here. So, what happens here is, when the input crosses, if you want to understand this, it is better you go with waveforms. So, when input crosses 2/3 VCC, what happens when input crosses 2/3 VCC? The upper comparator input crosses our 2/3 VCC. You can see if the output is initially I, it switches to a negative saturation, and when input falls below 1/3 VCC, it continues to be in low, and when it falls below 1/3 VCC, it again switches to an I. So, thus you have converted a sine wave to a square wave, thereby the two threshold points are 2/3 VCC and 1/3 VCC, enabling you to use your 555 timer as a Smith trigger. So, this is one simple application of your Astable multivibrator as a Smith trigger. So, we will take up the next application, that is application of an Astable multivibrator as a voltage controlled oscillator. Triple five timer as a voltage controlled oscillator. So, what is a voltage controlled oscillator? It is a circuit whose output frequency or output oscillations is dependent on the applied voltage, and the circuit goes something like this. It is an Astable multivibrator modified to be used as a voltage controlled oscillator. So, we have 8 and 4 which is connected to VCC, and between 7 and 8 we have RA, RB, we have 6, this is your capacitor, and we have, if you can recall the pin configuration, pin number 5 is a control voltage. So, this is used to control the voltage, power supply voltage to your 555 timer. Usually we keep it grounded, we connect it to ground through a capacitor. Now that because we want it to operate as a voltage controlled oscillator, what I do is I apply variable voltage using a potentiometer to the control pin of your 555 timer. So, the position of this position of the wiper on your potentiometer decides what is the control voltage given to the stable multivibrator, and you are aware the charging and discharging time they are dependent. It is charging from 0 to 2/3 VCC and discharges from a maximum to 1/3 VCC. Thereby, if you vary this control voltage, you can vary the charge and discharge time of a transistor. Once the charge and discharge time of your transistor varies, you can see it is varying the time period. When you vary the time period, you are varying the frequency. So, this is used as a control voltage. Increase or decrease the voltage, there is a change in the output frequency. Hence, such an oscillator we call it as a voltage controlled oscillator. So, with this we will complete the discussion on astable multivibrator. We will take up few problems on astable multivibrator before we take up the next topic, the final next topic, that is voltage to current and current to voltage converters. So, we will try to work out few problems on astable multivibrators. So, for an astable multivibrator, the given problem is, for an astable multivibrator, he says R1 is 22 kilo ohm. So, he has used a different designations, it is referring to RA here, and R2 is 30 kilo ohms, and the external component capacitance used is 0.5 microfarad. He is asking you to find the on period and off period of the astable multivibrator, and you are aware the on time and off time is something like this. During the capacitor time, the capacitor gets charged, it is on time, till then it is getting charged towards 2/3 VCC. Once it falls below 1/3 VCC, the capacitor the output switches to a low. So, this is how your astable multivibrator operates, something like this. So, now we are asked to determine T on and T off. So, just to recall, what is the circuit diagram of a stable multivibrator? It goes something like this. Pin number 8, 4, it is connected to VCC. Discharge transistor is connected to pin number 7, RA, and between RA between 7 and 6 we have RB, and 2 capacitor, 6, 1 is ground, 5 is 3 is here output, and he says capacitance value is 0.5 microfarad, resistance is 22 kilo ohm, this resistance is 30 kilo ohm. Now, you are asked to determine T on and T off. So, we have already derived expressions for T on and T off. T on is what? 0.693, it gets charged to RA and RB into C, and T off is 0.693, it discharges through RB into C. Substituting these values, 0.693 into 22 plus 30 into 10 power 3 into capacitance value is 0.5 microfarad. You will end up getting an on time of 18 milliseconds. Now, substitute the values here, it is 0.693, and it discharges through RB, and RB is 30 into 10 power 3 into 0.5 into 10 power minus 6, and the discharge time is going to be 10.395 milliseconds. And you are also asked to find the duty cycle and frequency. So, frequency is what? 1 by T, and the total time period is T on plus T off, which is 18 plus 10.395, which is 28.395 milliseconds. Substitute here, F is 1 by 28.395 into 10 power minus 6 and minus 3 milliseconds. So, it is 35.2 hertz. and you are asked to find the duty cycle also. Duty cycle is what? Duty cycle is the ratio of, try to recall, duty cycle in percentage is T on by T on plus T off. Substitute these values, and if you want to find it in percentage duty cycle, multiply it by 100. Substitute the value of T on 18 by total time is 28.395. So, it is going to be 63.39%. So, what it infers is 63% of the total time it is on, and remaining 37% it is off. So, this is the inference we have. So, for this particular problem, he has given with you, with the circuit parameters, circuit values, you are asked to find, you are asked to determine the on time, off time, frequency of oscillations and duty cycle. So, we will take up one more problem. A 555 timer is configured to operate in Astable multivibrator with resistance RA equals 5 kilo ohm, RB also 5 kilo ohm. Determine the duty cycle, and is also given you with capacitance value which is 0.01 microfarad. Is asking you to find the frequency and duty cycle. So, you are asked to determine the frequency. Frequency is what? Reciprocal of time period. So, I need to determine time period. So, to determine time period, it is the sum of on time plus off time. We need to determine on and off time, and duty cycle is the ratio of T on by total time. So, we will first determine on time and off time given the circuit parameters, later determine, substitute these values here, we get time period, subsequently we will get the frequency and duty cycle. So, just to recall, the expression for T on is 0.693, for an astable multivibrator it is 0.693 RA plus RB into C. So, it is 0.693 given two equal resistance. So, 5 plus 5 10 kilo ohms into 10 power 3, and the capacitance is 0.01 into 10 power minus 6. So, substitute these values, you end up getting an on time of 69.3 microseconds, and similarly off time is 0.693 RB into C. So, 0.693 into 5 into 10 power 3 into 0.01 into 10 power minus 6, you will get frequency half of this, that is 34.65 microseconds, and total time is going to be T on plus T off. Add these two, you end up you will get the total time period as 103.95 microseconds. Now, you need to determine the frequency. Frequency is 1 by T. So, 1 by 103.95 into 10 power minus 6. Substitute these value, you will get a frequency of 9.62 kilohertz. And the duty cycle, the formula for duty cycle is T on by T into 100 if you want to in percentage. So, T on is 69.3 by 103.95 into 100. You will see that the duty cycle is 66.67%. So, this is one more problem on astable multivibrator. We will work two more problems before we wind this session. Design an astable multivibrator using 555 timer for a frequency of 2 kilohertz. So, you are asked to design a astable multivibrator for frequency 2 kilohertz and duty cycle of 75%, and he also gives you the capacitance value to be taken as 0.1 microfarad. So, we are asked to determine a stable multivibrator for these requirements. So, first I will just write the circuit diagram of an astable multivibrator. So, we have pin numbers 8 and 4, which is connected to VCC, and I need to determine RA, RB for this particular requirements. So, he says the frequency is 2 kilohertz. When the frequency is 2 kilohertz, total time period T is 1 by F, it is 1 by 2 into 10 power 3, which is going to be 0.5 milliseconds. And he says the total time period is 0.5 milliseconds, total time period given as 0.5 milliseconds, and out of the 0.5 milliseconds, 75% is your T on and 25% is your T off. When I say duty cycle of 75%, T on is 75% of the total time is T on. So, we can easily compute T on as 75% of the total time, that is 0.75 into 0.5, and T off is 25% of the total time, that is 0.25 into 0.5. So, it is 0.75 into 0.5, you end up getting 0.375 milliseconds, and T off you compute it is going to be 0.125 milliseconds. Now, things becomes easy. So, we have an expression for T off is 0.693 RB into C. Now, you can easily find the value of RB. So, RB is going to be T off by 0.693 into C. So, T off is 0.125 milliseconds divided by, milli is 10 power minus 3 divided by 0.693, and the capacitance value is already given it for you, it is 0.1 into 10 power minus 6. So, substituting, RB is going to be 1.8 kilo ohms, and you substitute this value for for finding out RB, which is T on, as RA plus RB into C, which is 0.375. You substitute these values, you will get a resistance value RA equal to 3.6 kilo ohms. So, if you are asked to design a circuit for given frequency, given duty cycle, you follow these steps. So, your RA found out is 3.8 kilo ohm and 3.6, and RB is 1.8 kilo ohms, and this meets the given requirement. So, you get a output of frequency 2 kilohertz with a duty cycle of 75%. We will take up one more problem. You are asked to find construct a stable multivibrator for a duty cycle of 0.25. So, please note here the given requirement is 0.25. So, what it means is you are supposed to generate output wave wherein on time is greater than off time, and you are aware with this is on time is 25% and off time is 75%. So, with the regular astable multivibrator, what we have is, we have the circuit which goes something like this, usual circuit, without any modification. Your astable multivibrator is something like this. to the discharge transistor RA, sorry, and here we have RA and we have capacitance connected. So, if you can see, it is always it is getting charged, the capacitor always gets charged through RA and RB and discharges through RB. At no point of time your T on can be less than T off, can be less than or equal to T on T off. So, what we do is for a square wave generator, what we do is we bypass this resistance by connecting a diode. So, thereby the capacitor charges through RA and discharges through RB. Now, you can, by taking equal values of RA and RB, what we can do is we can obtain a duty cycle of 50%. Now, it is not 50%, instead the given requirement is a duty cycle less than 50%. So, what we do is, as usual, we connect a diode across RB so that it gets charged to RA, modifying your charge expression as 0.693 into RA into C, and it discharges through RB bypassing this because this diode is reverse bias, and it becomes the discharge time becomes 0.693 RB into C. Now, what we do is, if I choose an appropriate value of RA and RB such that it is 0.25 percent of the total time is your on time and 0.75% of the total time is your off time, we can get a duty cycle of 0.25. So, this is what is required here. So, now because of this modification, your T on is what? T on is 0.693 RA into C and T off is 0.693 RB into C. And the frequency is giving is 2 kilohertz. So, for 2 kilohertz the time period is going to be 1 by 2 into 10 power minus 3, which is 0.5 milliseconds, and therefore T on is what? 0.25 into 25% of the total time, 0.25 into 0.5 milliseconds, which is going to be some value, and T off is 0.75 into 0.5 into 10 power minus 3 some value. Now, I will leave this as an assignment. I expect you to compute the value of RA and RB corresponding to this. I will make it more simpler. It is 0.693. This is going to be RA in C. Substitute the values, find out the value for RA, and this is 0.693 RB into C. Compute the values. Once you get this values, substitute. It is just only substitution is remaining. Substitute the value of C. Let us assume C is 0.1 microfarad. Substitute these values. Arrive at the value of RA and RB, and accordingly you will get an Astable multivibrator which has been designed for a duty cycle of 25%. So, you could be asked similar problems. You should be able to design for the given requirements. So, with this we are completing our discussion on 555 timer. So, what a 555 timer is, how a 555 timer can be, what are the features of 555 timer, what are the applications of 555 timer, how 555 timer can be connected as a monostable multivibrator, astable multivibrator, applications of astable, applications of monostable multivibrators. So, with this we wind the topic on our discussion on multivibrators. In the next session we will take up the application, we will revisit the application of op-amps and see how op-amps can be used as a voltage to current and current to voltage converter, and also look into what regulators are. So, we will wind today's session. Thank you.